All right, so by the way, anytime you're approaching a rational integral, right, this is an integral of a rational function, so we call it a rational integral. The first thing you should check is the numerator the du of the denominator? In other words, could I do this by a substitution? Because if I could, that's way easier than anything else we could do. So we're always going to check that first. The du is 6x minus 5 dx. There's no way I can match it with that. All right, not by multiplying or dividing by a constant. So no u sub. I'm not going to do that. But we should always check first. All right, now, once we've decided that we can't do a u sub, the next thing is, can I factor the denominator? And by the way, if you can't, there's a whole other thing we got to do. But that's for 2 days from now. So what we're going to do now is we got one, oh, I can factor that. So let's look at the factors. So let's just look at if I have 1 minus 3x over 3x squared minus 5x plus 2. So what I'm doing is I'm pulling out the rational expression from the integral, and I'm doing some scratch work with it, and then I'm going to put it all back together later. All right, but even though I'm doing that, everything that I write is correct and complete. So I'm going to say, okay, first of all, I'm just going to factor the denominator 3x minus 2 times x minus 1, and then I'm going to say that 1 minus 3x over 3x minus 2, okay, I could probably have written this in a single line instead of 2 different lines, equals a over 3x minus 2 plus b over x minus 1. And you're going to say, okay, I'm going to take my rational expression, I'm going to factor the denominator, and then I'm going to put an a and a b for each factor. So this line you can skip. All right, so then the next line, we're going to multiply everything by 3x minus 2, x minus 1. You'll get used to doing this step efficiently. We have 1 minus 3x equals a times x minus 1. We're cross multiplying over here, plus b times 3x minus 2. Now I just distribute out the a and the b. See, the nice thing about this, even though it's a little bit obnoxious, it goes the same way every time anyway. 3bx minus 2b. I've already made 2b jokes, so I'm not going to make any more Shakespeare jokes about that. 1 minus 3x. Oh. So, all right, so I've already done that, so I don't need to do this. I'm just going to equate the x parts, watching that you keep your sign together, which when I worked this out ahead of time, I did not. I was like, I work these all out ahead of time, but I mess it up, so what's the point, seriously? All right, and then I have ax plus 3bx, so that tells me that negative 3 equals a plus 3b. All right, and then when I equate the constant parts, the 1, the minus a, the minus 2b, I have 1 equals negative a minus 2b. All right, now I could do substitution on this. It's easy to do, but look how much easier it is to do elimination because the a is already eliminated. So I can just add these two equations going down. So negative 3 plus 1 is negative 2. The a's cancel out, and I just have b. So b just right away equals negative 2. How easy is that? And then I can take my b equals negative 2, plug it into either one of these. I like this one because it doesn't have as many negatives. So negative 3 equals a plus 3 times negative 2. That's using this equation. So negative 3 equals a minus 6, and 3 equals a. All right, so now what I know is the b is negative 2, and the a is 3. That means, and so I'm going to use those with these expressions up here. So now that I've worked out all this about finding the a and the b as sort of a separate scratch work, now I'm going to come back and work with the integral. So I'm going to put that integral back in, and I'm going to say that integral of 1 minus 3x over 3x squared plus 5x plus 2 dx is equal to the integral of, all right, so you got to watch which one's a, which one's b. The a goes over the 3x minus 2, so it's 3 over 3x minus 2 dx. And then since my b is negative, I'll just put the negative out front. So minus 2 over x minus 1 dx. All right, so that is that. And then, yeah, so we can, you can do various things with this. So I'm going to go ahead and pull out the 3 whenever, because I'm going to show this. I think this will be the last time that I work through all of it this way. I'm going to pull out the 2. So I'm just getting 1 in the numerator. All right, and then I'm going to say, okay, this antiderivative is ln of absolute value of 3x minus 2. But because it was 3x, remember I'm using the derivative of the inside function, which is 3, and I'm multiplying times 1 over g prime, so I have to go times 1/3. All right, this one, I'm still really doing the same thing, minus 2 ln absolute value of x minus 1, but this time the derivative is 1, so I don't have to write it. All right, now once I've done all the derivatives, I put my plus c. It'd be nice to at least cancel the 3 and the 1/3, so I have ln absolute value 3x minus 2 minus, that canceled, minus 2 ln absolute value x minus 1 plus c, dingity done.